Hi everyone, I'm Matteo Maria. Today I'm going to talk to you about FFI. How many of you already know what FFI is? Just to, okay, that's too many people. So let's start talking about wait a second, sorry, okay. What actually FFI is. For people who don't know. FFI is a mechanism which lets you call functions from one language to another one, making them to communicate. You basically create an interface to translate one function to the other language, and then you can call functions wrote for example, in C, like I did for my example that we'll see later, in Dart, okay? And that's the whole process that is that you use. It's basically magic, because you don't see any of those steps in your development. But yeah, using the FFI package that is built in Dart, you can achieve the implementation of native library in your application. So why should I use FFI? An example could be the use of pre-existing library. So for example, I put there OpenCV or FFmpeg, which doesn't make sense, in my opinion, to recreate in Dart, because they already exist and they are maintained already in other languages, and they are performant for their purpose, so it doesn't make sense to rewrite them from scratch. And also for performance, and we'll see later why performance are somehow better in low-level languages. So before to start, which platforms support FFI? You can use it on every platform that is supported by Flutter, but with the exception for web, that is not directly usable. So the FFI package is not supported on web, but you need to compile the libraries for WASM and then use the JS that is generated with the JS interop library that is available on pub.dev. So what we're going to see today. I created this demo, which is a n-body simulation. Those are little particles that are orbiting one around the other. And in order to achieve this, I used a custom painter that is drawing them on the screen. And since that operation is kinda expensive, I think it's a good benchmark to see to compare different languages to create those particles. So let's start to create the first integration. So I first of all created my project, and I added FFIGen plugin package. Sorry, the FFIGen package lets you generate Dart code from C files, C header files, and we'll see later how. And then we'll create the C plugin. The creation of the plugin folder and also the creation of a plugin, it's not needed to achieve what we are going to see today, but I created them to organize better my project. So I created the folder, and then I created the first plugin. As you can see, I listed all those platforms, but it's not needed that. You just need to add the platform that you need to deploy your app to. And then there's the flag template and plugin FFI, which is a built-in template in the Flutter create command to just create the boilerplate for your FFI plugin. So what we see inside the generated plugin, there are a lot of directories, and the one that we're looking now is the SRC. We have three files. The C file that is generated, just an example, with a sum function, and another sum function that is that presents a sleep. So it's just to have two different cases where one is you run it instantly, and the other one is it's taking a little bit longer. Okay. Then there's the H file, which just defines the signature of those functions. And then there's a cmakelist file, which is used for compilation. After that, we can see in the main directory of our plugin that FFAGen YAML file. This is also generated by the Flutter create command. And this file is needed by the FFAGen package to understand where to go to get the header files for our plugin and generate the Dart code from it. So as you can see, there's the entry points, the entry points label, okay, to tell FFI where to get the signature of our methods, okay? And then we run that command to generate the Dart files. What we see generated is that file, okay? Inside of it, there are our sum function, okay? The short one and the longer one, okay? And those are the mapping from the header files in C and the Dart code. And the other file that you see there, it's created by the Flutter create command, but you maybe need to edit by hand, because it's just a over-engineering way to call the function that we see earlier, okay, but in a more readable way. And also, they already put there the switching between the different library naming that are going to be created for the different platforms. Because on Android and Linux, we have a .so file. On Windows, we have a DLL, and so on. And that's all. After that, we just need to go back in our app, go to the pubspec.yaml file, and add our plugin with the path flag label, okay? And then we just use it like every other package from pub.dev. So if we go in our app, I just used an empty app, and I added my C plugin, and then I added our sum, and it works. So yeah. And what if you want to integrate something other than C? Because C is free to use. So you just create your C code and you put it in your app, and it's bundled inside your app for free. So you don't need to do anything, okay? I brought as an example Rust, but you can use every other language that can be compiled, okay? So for example, Python is not usable unless you can somehow use things like Cython and things like that. So it needs to be a language that can be compiled, okay? And I brought Python, Rust as an example, okay? So I create the same plugin as before. I go inside my SRC folder, but this time I need to create my personal Rust project, okay? So I run the cargo new FFI project with the flag lib, and inside my cargo.toml file, which is like the pubspec, okay? Under the lib section, I added this create type, which is going to tell Rust that I want a C dynamic library, okay? And like before, I have this pre-generated file with an add function. I just need to make some changes to that function, like the num angle. That decorator is going to tell the compiler that I don't want to, during compilation, functions are renamed to make them unique, and so many other labels and names and numbers are added to your function name, and that can make a problem with FFI because you don't know actually how it's going to be renamed, and you can't call from Dart. So adding the nomangle decorator is going to tell the compiler, leave my function name as this, so we are going to have add, and that's all, okay? And also the pub extern C is going to tell that we're going to use it with a compiled C version of our function. You have to keep in mind that every function that we are going to use with FFI needs to be compatible with C. So we are always using C headers to translate to Dart, okay? After that, I just changed the type of my numbers, and just to be usable in C. And then I edited my CMake list file, and I added that part that is going to always run cargo build every time I compile my package. And after that, just like we did in C, I added my plugin to the pubspec.yaml file, and then, just like before, it works, okay? So everything good? Yes, but not exactly, because if you have macOS or iOS, it's not finished. Because C is bundled by default, but the CMake list file that we see earlier, it's not used on macOS and iOS. So that part that is going to build our cargo project, in case of Rust, but it's the same thing with all other languages, it's not going to be run when we build our application. So we need to build our library by ourselves and link to our app. So in my case, I went inside my Rust project, I ran the command to build the release, and then I got my library there, compiled. Then I had to go to our Flutter application, open the XC workspace file, and then link by hand the library. So we add it to the framework part of our runner. And so we do add file, we link our library, and then we put it there. So there's the link binary with binaries, and it's really important to put it that as optional, okay? Then there's the copy bundle resources part and the bundle framework. And that's all. Easy. So now there's a demo. So I'll show you the part with, okay. I hope that everything works. Okay, while it's running, okay, it's already running, okay. So that's the simulation. As you can see, we achieve 20-ish FPS with Dart. Okay, the Rust logo is not so visible, but yeah, okay. So that's not really good, because 20 FPS nowadays, it's really slow. Switching to Rust, we are in a really better situation, as you can see. And now I'm going to switch to C++, but I have to make a disclaimer. So in my previous presentation, I had an M1 MacBook Pro, and I achieved with C like 70 FPS, something like that. And I don't know why with the M3 I get 13, but trust me, it's something with the compiler, the flags that you pass to the compiler, which I don't know. So it's not like that. You have to play with the compiler, but yeah, you can achieve like 70, 80 FPS, but less than Rust. And before going to the fourth language, I'll explain something to you, but I want you to think about which language could be the fourth one, okay? And then I'll ask you someone in the audience. So how this demo, in my opinion, can be a good benchmark of a good comparison for those languages. The first thing is that I'm not rendering the particles in the other languages, but they are only responsible for bringing to Dart the list of particles, okay? So they are all painted with custom painter, okay? And second thing, I used the same exact garbage code that I wrote myself. And from one language to another, there are no differences in code and optimization and things like that. So they are exactly done the same way, okay? So do you have any idea which language could be the fourth one? Someone can try to guess. Please, no, it's not Swift.
Go.
What?
Go.
No, it's not Go. Not Kotlin, not C#, not C#. Not assembly, I'm not that crazy. No, C, there's already C++, so no. Not Mojo? First, I'll show you the performance of that language. Okay, as you can see, it gives you a fair amount of FPS. More than 60, it's good, okay? So let's continue. No, please. What? D, no, it's not D. Not Scala? No. Well, I heard something. It's Dart. Again. It's Dart again. Why? Believe it or not, it's the same code. I'll show you later. It's exactly the same code as this one, okay? So, same thing. But the main difference is that here, I'm using typed data, okay? What are those types? Let me show you. If we go there, okay. This is a library that is inside the core of Dart, okay? And those types, as you can see, are only numeric types, okay? So there are float lists, there are int lists, byte lists, and things like that. So you only have numbers, okay? But those numbers, those types are faster. Why? Since in Dart everything is a class, okay, we get a slowness in using types for one single reason. When we want to store an int, a double, a bool, or things like that, the data is stored in memory and boxed, okay? And every time we want to change or every time we want to change that value, the value is going to be unboxed, changed, and reboxed, okay? And that operation can be expensive over time, okay? And that happens also with classes that we create. So if we want to use I don't know, if you want to create a point class, okay, X, Y, and things like that, every time we want to change that point, it's going to be slow because we need to take the point class from our memory, unbox it, go inside of it, search for X and Y, unbox it, and then change the value and rebox everything, okay? And Dart is smart enough to optimize that in some cases. For example, if we create a sum function that is going to have 2 int as parameters, those values are not going to be boxed because Dart knows that we are going to use them as they are, okay? So it's going to be faster. But in all other cases, so for example, when we are using the vector math library, where there are vector2, vector3, and so on, those classes are slower because all the values inside of them are going to be boxed, unboxed every time we try to change them. So those types are not boxed by default, so they are actually faster, okay? So let me show you. I'll try to zoom. Okay, can you read it? Yeah, kind of, perfect. Okay, so don't look at the code, it's terrible. But yeah, no, okay. Okay, as you can see here, okay, here I have 2 lists of double for the acceleration of the particles, okay? And as I told you before, double is going to be boxed and unboxed every time. So reading all that values from the list, change them and resave them is going to be really expensive. I have in my presentation 3,000 particles. So it's going to be 2 for loops for 3,000 particles every time. And as you can see, my particle here, okay, I have a double for the mass, 2 vector2, 1 for position and 1 for the velocity, and then another double, yeah, a color for the painting part. And the other version with Dart changes, it's different only with that part. So wait a second, okay, here. As you can see, the position is split in 2 doubles, and also the velocity is split in 2 doubles. So that single change is going to make your app more performant, but also inside that's the Dart version, sorry, the other one, yeah. As you can see, I don't have a list of double, but I have 2 lists of float64 list. So this is typed data, and just that line changed is going to give you 40 FPS more. And that's all. You have to trust me, but it's exactly the same code. No, it's a pure Dart. Yeah, it's pure Dart from scratch. And for the FFI part, I just compute the particles in C and Rust, and then I return a pointer to that list. So Dart is going to bring the list using the pointer, dereference it, and painting on the canvas. And that's all. You have any question?